There you go.
Love it.
Hey,
Well, fantastic. Well, first off, thanks for having me. I was just telling these guys I became eligible for retirement literally last week and was pretty excited about it. So I'm not retired yet, but I aspire to be you guys not too distant future. Well, thanks for having me. I'm going to talk about, as Lisa alluded, somewhat of a new topic for most. As she mentioned, I'm program manager for the Center of Excellence for Collaborative Innovation. This actually came about out of Dr. Jeff Davis's work about 12 years ago out of what was then Health and Life Sciences. And he basically did some pilots in this area, and I'll talk about what this is, and had some successes in it and started implementing it in SA and HHMP. And what he found was that OSTP, the Office of Science and Technology Policy at the White House, came along in 2011, said, hey, you guys seem to know what you're doing on this stuff, and we really need this to be something that the rest of the federal government understands and uses. Can you stand up a center of excellence? And so they talked to Gerst, and Gerst agreed to allow NASA to stand up the center of excellence. And so now we work across the entire federal government, as well as across all the NASA centers, to really help folks understand what these tools are, why they're needed, and then to help them use them, because new tools, as we all know, are not easy to use. And so that's what we are. I'll come back a little bit more just to let you know, organizationally, we fall under STMD now, and that's kind of where we get our funding from, but we're based out of Johnson, really under a STEMwinder office for Vanessa, under the center director. So what you guys might remember is that when it came time, and somebody needs to mute, I'm getting a little bit of an echo, so if you can just check your mute button. But when you start to put a new system in place, the very first thing you do is you need to find the cutting edge technologies that are going to be the basis of your new radio or space capsule, whatever you're building, right? And so there's the discovery phase. And, you know, throughout my career, that's been going to some conferences, talking to some experienced folks, going out to vendors, and really trying to understand what the landscape is, picking those pieces, kind of developing some of them if you needed to, getting them into a design, and then spending the big bucks and the big amount of time implementing that design, right? So that's how we innovated. That's how we would go through new systems builds. Here's the thing. It turns out the world has changed, and I'm not telling you anything that you don't hear pretty much on a daily drumbeat these days. But what we're finding is that a lot of the methods that we've used for decades, if not hundreds of years, are starting to actually not work. And I've talked a little bit about why we think that's the case. One is, this is population. I bet you didn't expect you were going to see this chart today, but this is the last 2,000 years, and the first doubling of the population was, you know, from the Common Era, from the year one, was 1,400 years in. It took 1,400 years to double the population, but in the last 50 years, the Earth's population has more than doubled. And in that time, many of the countries around the world have gotten more wealthy. They've established learning institutions and universities. And so now we're in the situation where over the last 20 years, the number of people that have exited secondary education has more than doubled. That is huge. And if you think about all of the, what I call dead scientists, right? Except I don't think all of those guys are dead yet, but all of the scientists that ever existed on the planet that pretty much came up with biology and engineering and calculus and physics, that if you added all of those scientists and engineers up, they would only account for 10% of the scientists that have lived on our planet. The other 90% are alive and working today. That's how big this population shift has impacted us. And we're seeing it in this tsunami of technology, is what I've decided to call it, because all of these scientists, engineers aren't just sitting on their hands. they're using a lot of these new building block technologies, 3D printing, new processing capacity, machine learning, nanomaterials, drones and autonomous vehicles, complex robotics, quantum computing, open API software, blockchain. And each of these technology building blocks is actually masking a tremendous amount of complexity underneath the covers. But at the usage level, they're made to be used very easily. And in fact, most people can get online and take a course and in relatively short order, learn how to use these tools. I actually had one of our folks that competed on one of our challenges. She was a psychologist, and within a few months of working on our stuff, had learned CAD, computer-aided design, and bought a 3D printer, learned how to use it, and then went off and learned how to make robotics components. These things are really powerful, and just almost anyone can do it. Here's the thing, though. The most fascinating thing about these really powerful building blocks, and these aren't even the full list, right, is that this set of technology doesn't apply to a single industry. They apply to almost every industry. And that's where this explosion of technology, the tsunami of technology is coming from. Because if you take, let's say, all the disciplines across the globe and say, okay, this is all the different industries, and then they're getting more complex as we go up, then, you know, we at NASA, we have this one little slice of it that we're responsible for. But if we look at what are the efforts going on, let's just say in machine learning across the different industries, then we would see something like this, right? Where NASA has a lot going on. We have a lot of some of the cutting edge stuff. But if we were to look at that far right top, that leader is likely to be someone like John Deere, who you might not realize it, but is a leader in AI and machine learning and advanced manufacturing. But if we went to that meeting as an aerospace person, and they talked about their farming problem, and they talked about their farming technologies, and they used their jargon, and they described how they were using machine learning, we would easily walk away from that meeting and think, you know what, that's great for them. That's not helping me at NASA. But the reality is, a lot of these technologies, because they're using some of the same components and because they're just addressing a different problem, can actually have application to our problems. But it takes that translation, that connecting of the dots. And we are seeing this over and over. And the pro for the world is this tsunami of technology means that there has been no other time in history that we've had so many amazing technologies at our fingertips coming online, getting really into the mainstream and kind of flooding us. The con is if you're an engineer trying to leverage these technologies, you can't find them because that tsunami is so large. Many of those technologies are behind technology firewalls. They're in other industries, and we don't actually have ways to reach across those boundaries as we could. So that funnel that we talked about, that way of doing design has been modified a little, right? Instead of just a few things that we need to look at, now there's many, many more options that we need to be considering. And many of them are hidden to us. And the risk to us, as we all know, is if you don't lock in on the right technologies and bring them into your design and start using them, then when you go off to go build, you're going to get halfway through and someone's going to come out with a design that works 10 times better than what you're trying to build. And you suddenly have to go to the program manager and say, hey, look, we got to decide, do we want to throw away that couple $1 million we just spent on this development and go with this new, better design? Or do we live with the substandard design for the life of the program? That's not a great choice. And we have to have better ways of finding and tapping into these disruptive technologies. The rate of change of knowledge and technology, it just continues to increase. It's not going to slow down. It's going to get faster and faster. And it's going to make it harder and harder for us to find the skills and expertise and keep up with the tech advances that are happening. And the risk to the agency, as well as to businesses, is remaining competitive and relevant, right? if suddenly SpaceX or the Indian Space Agency is putting up payloads at a fraction of our cost or making telescopes that can see 100 times better, the taxpayer is going to wonder, hey, what's NASA doing for us, right? So we as NASA have to stay competitive in our technology and find a way to tap into that technology tsunami. Here's the thing. This disruption is actually hurting everyone. It's not just us, right? If you look, this is kind of a dated chart, but over a 15-year period recently, over half of our most successful companies went away. And in fact, if you look at the trend, and this again is S&P 500, so some of our most successful companies, in the 30s, the average lifespan of those companies was 90 years. By 2018, it had shrunk to 18 years. And the latest report I heard is 14 years. So this disruption, the rapid change is changing the way organizations can adapt and their ability. I'll just give you a quick example. This Subsea 7, some of you might know of them if you're around the oil industry. They basically do a lot of things, but one of the things they do is pipeline bundle inspection. So offshore oil rigs have pipelines that pipe the oil back to shore, and they'll take a ship out at $1 million a day, and they'll lower a van-sized piece of hardware next to that pipeline, and they'll run that piece of equipment next to that pipeline bundle for about 2 weeks to scan it. They did a challenge with 9 Sigma, and I'll talk more about these later, but within 2 weeks, they found that in the mining industry, there was a technology that was handheld that could do that same job in 2 hours. And what they told us wasn't, wow, we're going to save millions of dollars. What they said was if they hadn't found that company and acquired it, by the way, and their competitors had, they no longer would be in the pipeline inspection business. And this is the kind of disruption that rapidly kind of bleeds over from some other industry and can really like mess with one of our industries, right? So coming back to our chart, if this is our team that we hire, right, and we have a kind of lower floor, we only hire people of a certain skill level, and then we're the government, so we can't actually hire the really expensive ones. If we're trying to tap into these innovations that are out there waiting for us to go harness and use in our designs, then if we put an individual on that, they're going to be able to access some of that, especially if they're trained in innovation. If we put a team on that, they're going to have better coverage, but it's still a fraction of what's out there. And it turns out that if we can actually activate the crowd, and I'm going to talk about who that is, we can statistically act as a dragnet across the entire different set of industries to find these technologies. And that's what we call open innovation. That's what we talk about crowdsourcing. It is these platforms, these websites that bring together and curate very large numbers of people from around the world with different skills and backgrounds that can then help solve problems and find solutions for us. It's kind of like we talk about these crowd platforms that are providing this low friction matching at scale. And that's how I like to think of it, because it's kind of like Uber. I'm sure a lot of you have taken Uber now, where you get your mobile phone and you need a ride, and the app has a bunch of members on it who are drivers, and it matches you to someone who can give you that ride, and it has them show up in 5 minutes and take you where you need to go. And it's all with just a few clicks, right? I never forget when this first came out, and I thought, oh my gosh, who would ever get into a stranger's car? They're going to murder me, right? But now everyone does it. Nobody thinks twice about it, right? Same with Airbnb. I'm never going to sleep on somebody else's bed. That's crazy. And now go to Airbnbs all the time, right? And it's all on this platform concept of getting lots of resources on the platform and then matching them to some customer need. So that's who we work with. We work with a bunch of these, what we call curated crowd platforms. These are websites who kind of have two-sided networks, right? They recruit users. So Topcoder has recruited 1.6 million software developers and data scientists to become part of members of their platform, right? And what they're offering them is connection to other people who have that same passion and interest, to training opportunities and opportunities to try out their skills and maybe even win some money or earn some money. Spark is our internal NASA platform. I'll talk a little bit about. That's 30,000 of our employees that we ask questions to all the time at NASA. GrabCAD, 11 million mechanical engineers and designers who all gather on a site really to exchange models and up their skills. Freelancer, they're no longer 67 million. They're over 70 million members in that one crowd. And that's suspiciously close to 1% of the world's population in one community. And we can ask questions of them and use them as a dragnet. Wazoku and HeroX, they actually are crowds that have people from every discipline. They're not specialized like Topcoder and GrabCAD. They have people from every technical domain, and they're filled with people that just love hard problem solving, probably like some of you. And these people are winning, $100,000, $50,000 prizes for their solutions that then industry takes on the other side of the network and takes back and solves their problems. So that these platforms match what these people can do with problems that industry and organizations have. Now, the theory goes something like this, right? That for a given expertise, if expertise is what you need, the general population looks something like this. The peak of that crowd is probably your high school graduates, and then you kind of come down, you get fewer college graduates as your expertise goes up, and then you have your few world's experts way out to the right. And if you're like NASA, right, and we were NASA, basically, we don't even hire people until they get to that right side. And we have some of the world's experts as well, right? But what I tell our workforce all the time is that's absolutely true, except we are actually much smaller. It's 60,000, if you're generous, between all of our contractors and civil servants. I think we've actually shrunk closer to 50,000 now. And so the opportunity for us, because all of our smart folks are busy, is if we can tap into those folks that are as smart or smarter than us, then that's a win for us, right? And it turns out that these curated communities have some of those people. They're not totally made up of that, but they have them. Now, here's the thing. Expertise isn't always the thing. Obviously, most problems are made up of multiple disciplines, and we talked about multiple industries. If I take all those and kind of put them next to each other, you often find your solution is in another industry, and those people that connect the dots often don't have to be on the right side of the curve. They just simply have to connect the dots. And in fact, that's what we see quite often. There was a MIT study done a few years ago where they looked at all of one of these platforms' successes, where this company they were solving, using the crowd, hard problems that industry literally had spent 5 to 10 years trying to solve and couldn't solve themselves. So they would hand them to Innocentive. Innocentive would solve them within a couple of months. And what they found when they analyzed all those problems, that they found that 70% of the time that a challenge was solved, the solution provider, the person that gave them the answer, was not in the same technical domain as the problem owner. In other words, if you were a chemist trying to solve a chemistry problem, 70% of the time, the person that would solve that problem was outside of chemistry. Now, maybe they had a chemistry background, but they actually brought something else to the table. And 75% of the time, they already had the solution. In other words, it existed, and they were simply connecting the dots and bringing it to bear. So we talk about the statistical kind of dragnet and how do you do it, but how do you do that, right? And it turns out that there's a kind of a magic algorithm for this, and it's called prize challenges. And that sounds weird as an algorithm, but it is the mechanism that is able to find and narrow the solutions that are best for your problem. Now, these communities we talk about, these companies, they are actually very good at formulating the problem statement, which is really important, designing that challenge so that it actually has the right prize amount, has the number of prizes, has the right duration, the right advertising. They can execute the challenge. They have the website for it. They have the terms and conditions all set up. They know how to solution filter. We had a challenge where 5,000 submissions came in, and we actually had in our contract with HeroX, the crowd that we were using, that they had to actually only provide us those submissions that met all of our criteria. And that was not 5,000, but only 87. And they did that work for us. And then they help you pick the winners and deal with the intellectual property, whether that's licensing or transfer or keeping it. There's all sorts of stuff. They know how to use it. They've worked that legally, and they can actually help you also protect your intellectual property. So let me give you a couple examples. Frito-Lay came into, I believe it was Frito-Lay, came in to talk to Innocentive, and they said, look, we have a problem we'd like you to try to solve. We need a better way to remove grease from our potato chips. I just took this to Europe, so it says crisps, but you're all men of the world and women of the world, so you know the term in England for potato chips. So how do we remove grease from potato chips? And it turned out that the way they were doing it was they were vibrating the tray of chips as it came out of the vat of oil, and that would shake off the oil, but it would also break some of the chips. And I like to point out to people that most food production engineers are mechanical engineers, and our specialty is vibration. And you can really see that in this solution, right? So the first thing that Innocentive did was they changed the problem statement from how do you remove grease from potato chips to this. How do you remove a viscous fluid from a delicate wafer? Same problem, right? Very different statement. But this statement does two things. One, it hides the fact that this is a potato chip company, so they don't have to worry about their competitors. But more importantly, it actually expanded the number of people that would look at this problem. It's no longer a problem where only food scientists and food production engineers would be interested in solving. This is now anyone with a physics background would go, that's an interesting question. Let me go see what I can do. And so broadening that to get the diversity of solutions is really important. Here's what happened though. They actually got a solution that won, and it was to acoustically vibrate the air around the chips with these big bass speakers, right? At a resonant frequency that causes the oil to kind of fly off the chip without damaging the chip. And what I like to point out here is this is a vibration solution that the mechanical engineering vibration specialists remain blind to for decades, but that a violinist submitted because she had seen the rosin kind of dance around on her stand when she played music, is also a vibration specialist, just a very different kind, and knew kind of what this resonance idea was, right? This is the kind of unsuspecting kind of statistical anomaly that we get with crowdsourcing. Roche Diagnostics, another case study out of London Business School, they actually came, multi-billion-dollar pharmaceutical R&D company. They had a problem that they were trying out in Innocentive, and they said, look, we've been working on this for 15 years. They needed a very precise way to measure the inlet sample quantity and quality for this sensor. And they'd worked on it for 15 years, no joy. They went to Innocentive, and after 60 days, they had a public challenge for about $10,000 prize. They actually were able to find, not from one person, two people submitted the same solution because, again, it already existed in some other industry. They just didn't know about it. But what blew them away was when they looked across all of the submissions, they found everything that they had tried over 15 years in proprietary research had been replicated in 60 days by a community that wasn't specialized in bioscience. And this is part of the story on innovation, is it's about rapid failure as much as it's about the success. Innovation requires that you get the full set of ideas so that the best ones can rise to the top. And if you try to do that by yourself, that takes a very long time and is very expensive. For this, you don't pay anything for the losers. You don't pay anything for the ones that don't work. So this works even better with data science. Harvard was trying to actually do an experiment to try to see why this was happening. So they actually took this NIH algorithm. This algorithm would take about 4 hours to process a sample, had an accuracy of about 0.72, so you get a couple of runs per day per machine. And they actually assigned two postdocs who were expert data scientists and experts in this field, and they paid them $120,000. And over a year, they produced a solution that was an order of magnitude improvement. It could run in less than an hour at 47 minutes and increase the accuracy at the same time. A huge boon, right? An order of magnitude better. They then ran a top coder challenge in 2 weeks for $6,000 prize. And at the end of that, they had an algorithm that could run 16 seconds at an even higher accuracy. And what I like to point out is on this chart right here, this is, logarithmically getting faster as you go right to left. That big red dot's the winner, but those 25 dots to the right are all the losers who all had solutions 2 to 3 orders of magnitude better than the original. And in fact, there were 89 different approaches out of this, and in data science, that is gold. It means you can get even farther. So if I tell people, if you have any data science going on, this is the place to start. And we have a lot of that going on now. So back to our organization. Again, we work across the whole agency and across the federal government through interagency agreements. Our public brand is the NASA Tournament Lab. So you're from the public, you wouldn't hear about the Center of Excellence for Collaborative Innovation. You would hear about NASA Tournament Lab. And what we do is we put together the contract mechanisms so that we can rapidly access these kinds of resources. And then we have the processes and the helpers to help projects use these to their benefit so that they will have a good experience and not, anytime you learn something new, it's a nightmare, right? We have to make it not a nightmare because these are really vital tools for our teams to learn. And we have really worked across the world with other agencies, other governments, other companies to really learn from them and to help them. We're one of the few public entities that talks about this. And in the world, we're actually a leader in open innovation. I don't know if you know that about NASA, but we are actually seen as one of the cutting edge folks in this area, even though some folks have been using this longer. We have a toolkit, which is a lot of logos I apologize for, but we basically work with about 50 of these crowd platforms, these communities that have crowds to do various things. And what's interesting is we range all the way from multi-million-dollar projects down to things that work off a purchase card, where we can do things for $5,000, $10,000. And we have our internal crowd, NASA at Work, now NASA Spark. All told, if you add up all of those communities, it's over 200 million people that we have access to. Some of those are retired NASA folks, by the way. I'll talk through some of our platforms and some of the examples just to give you an idea. NASA Spark is our internal platform. Again, it's got this kind of what the page looks like. I'm actually working to see if I can get the NASA alumni somehow connected into this, and we'll stand by and see if I can make that happen over the next few months. But we've gotten about 30,000, 40,000 folks to join. I think it's about 25,000 folks on our current list since some folks retired. We've run several hundred challenges on here. Most are successful. Most have been implemented. And interestingly enough, we asked people, hey, if you had done this just using your regular methods, how much would it have cost? And it turns out it would have cost quite a bit more. And it tends to be a cost savings. What we find it's best for is it is a very effective way to tap into enterprise knowledge sharing. In other words, we have lots of silos at NASA because everyone's working hard, heads down on their project and program. But that also means the rest of the agency isn't benefiting from your learnings and expertise. And what NASA Spark does is it really kind of pings the rest of the community and says, hey, does anyone know how to solve this? And it turns out people are really sensitive about their work. And if you're working on lunar dust and you hear someone asking questions about lunar dust, you're like, hey, wait a minute, I'm working on lunar dust. You need to talk to me and this person, this person. And that's exactly what we want. We want that kind of reaction because we want you to share and team. And we get lots of collaboration that result from these challenges. They are free to all the NASA projects and projects. STMD funds this platform. We don't actually award monetary prizes. We award things like cool NASA experiences, like you get to drive the rover, go hang out in the VR lab, things like that. I'll give you one example. Some of you might know Robert over in HHMP. He was looking for a better way to measure urine volume in microgravity, which is kind of ironic. He actually worked with Jim Broyens on the urine monitoring system back on shuttle, which was this huge box that had a big rotating drum of urine. And I always tell people, if there's one thing you probably don't want to do in space, it's rotate a large drum of urine. But we were trying to find a better way, right? And so he ran at the time, NASA Work Challenge, and found over in the EVA lab over in Building 7 that they had come up with already a prototype of something not for use for this, but that would work to do this. and he was able to save out on a phase 2, phase 3 SBIR, so several years of work, million plus dollars in savings. Same thing with Mike Lester at KSC, who is looking for a better use for or using thorium over uranium for nuclear power. And it turned out through the NASA Work Challenge, he found we actually had some funded research at a university that nobody at his center knew about. And there was actually a guy about to retire in about 2 weeks that actually had a study done in the Apollo era in his file cabinet that basically was the information they were looking for. So a lot of this is not always innovation like a spark, but it's rather drawing on what people know and what they have. So our public, again, is NASA Tournament Lab. We do lots of those. One, I used to work on the disruption tolerant networking work with Adam Schlesinger, and they needed a way in that delay and tolerant network. So every time we go farther than kind of low Earth orbit, we need these delay tolerant networks. And the way they work, to be secure, you have to have these security key exchanges. And on terrestrial networks, that has to be done with very tight timing. And that's the very thing that the DTN network can't do when you start to go to the moon and Mars. And so they were looking for a solution, and they posted it on Topcoder. And it turns out the solution that was submitted was to use the Byzantine general-based design approach, which is remarkable because Stokes and I worked on X-38, where we used this exact approach to synchronize our voted computers. And it was what Draper came up with for our kind of voting computer for critical computer voting. And it turns out this exact same approach is what's needed to do the security exchanges. So it's kind of remarkable that the technology that we were already using was brought back to us through the crowd, right? The DTN team went on to do like 13 new challenges. That was really quite a time. We actually had a time where Jonathan Sauter out of JPL was running a challenge. They're trying to look at the feasibility of a Venus rover, and they're looking at mechanical ways to do things because electronics are really hard to survive on those, and so they're looking for as many mechanical. So we ran a Hero X challenge there. Remember, the last probes that made it to Venus only last less than an hour, and we're trying to send something that lasts 6 months or longer, right? And it turned out we ended up with 572 submissions on this with some really creative stuff, all for a little over $60,000. And the 5 winning solutions, people were going out and building full-scale rovers and demonstrating them as part of this, all for the chance at like a $20,000, $30,000 prize. So people, we are tapping into that passion people have about space exploration. They want to be part of it. And we find that a lot of the people that participate in these get the bug to get into STEM and to crank out more and more of this kind of design work. And it's really a great influence on the public. We recently did an ultra starlight shade structural design challenge with GrabCAD. This was where John Mather, who a lot of you might know him as a scientist at NASA who won the Nobel Prize not many years ago for his planet searching work. And he has a concept that he's working through NIAC to get one of these kilometer-sized star shades that we can build. And he wanted some early understanding of how would those work and fold and do the origami thing. And we put this challenge out on GrabCAD for $10,000. That's the total cost to us. And we ended up with 60 designs, 5 of which we awarded, and he was literally floored. He said, this really propels us forward in our NIAC work and allow us to get to a more feasible solution sooner. Similarly, Jonathan Sauter again came back similar to that project on the NIAC with self-assembling structures in space that they're looking at. And, you can kind of see the designs people are coming up with. These are not trivial designs, and they are putting significant work in for the chance at a NASA prize of, $3,000, $4,000, $5,000. It's really amazing. Spot the Station app. This is a new app that we just did with one of our crowds where they built the software, and it's got all sorts of augmented reality. If you haven't downloaded the app, it's really kind of cool. You can show off to your kids. And then this MagQuest is one that the National Geospatial Intelligence Agency is doing with us. This is going all the way from ideation through launch and operations. So this is a $35 million program that another agency is running on our contract, where they have actually gone from ideas on how to measure the magnetosphere in space, and now have 3 companies that are competing that will ultimately get prize money that will propel them through the launch and operations phase, and then NGA will do a data buy from them. This is the very system that will tell your GPS where north is. So this is global infrastructure that's being built on this kind of a thing. So it's pretty amazing stuff. And I will tell you, the people that they tapped into were amazing. Some, like Spire and other contractors, but some were literally designers that we had never heard from a few years ago, and now are heavily involved in multiple challenges. So we've done about 800 plus of these. Most are successful. And interestingly enough, even though cost savings is not the goal, we find that about 3/4 have cost savings, and that the cost savings is significant. We think we've saved on the order, this needs to be updated, probably about $155 million so far for the government. And you can kind of see it's not a one size fits all. We can actually go and find really great solutions. And what I tell our folks is, look, we're not trying to replace the innovation of NASA people. What we're trying to do is get you the best starting place for your innovation. You're you as the NASA engineer, you're the one that has to bring the solution forward and get it flying. You need the best starting point for that. So why not tap into the latest technologies, the best ideas, and then go from there? The last little part I'll talk about, and I know I'm long-winded, sorry about that, but it's something we discovered in 2017. We had been working with these crowds, and we started working with this crowd called Freelancer, and it turned out Freelancer did contests. So they did these open innovation things, but that wasn't their core thing. They were actually tapping into freelancers and trying to match them with jobs. And it turned out that there's some really interesting shifts going on in work that we discovered out of this and started monitoring back in 2017. And this study from staffing industry and others came out and said, look, there's a whole new shift coming where these platforms aren't just providing matching of people to cars or people to places to stay, but they're actually matching people to work and what they're doing. And these other platforms kind of emerged with Maven and Upwork and Freelancer. And the study that came out by Edelman Intelligence in 2017 said, look, we're seeing people move into the freelance economy and out of full-time jobs at 3 times the rate of people moving into full-time jobs. And by 2019, over 40% of average organizations' total workforce was non-full-time employee. And we started saying, wait, if this keeps going, and in fact, the study said by 2027, there would be more people in the freelance and gig economy than there would be in the full-time workforce. We said, this is going to be a problem for NASA, because if everyone moves to this new model and we only know how to hire full-time people, then we're not going to be able to tap into the skills we need. And so then COVID happened. And in 1 year, that increase was 34%. And so we're still in the midst of this really big shift where people are not coming back to work. In fact, there was part of that original Edelman Intelligence study said, look, they asked these full-time freelancers, how much would it take for you to come back and work full-time for an organization? And 50% of them said, there is no amount of money you can pay me to bring me back to a traditional job. That's how much the thinking has shifted. And part of it is that people realize with these rapid technological changes that they have to keep up. And traditional organizations are not upskilling people and getting them skilled in the latest. And so if they're going to do that, they have to do that on their own with this new lifelong learning. And in fact, the study showed more freelancers were doing this upskilling on their own than traditional employees. And in fact, even the World Economic Forum came out in 2020 and said, look, coming out of the pandemic, more people are doing remote work, accelerating their digital work, accelerating automation to the point that many of our jobs that were people in 2020 are going to be machines in 2025. And that they looked at that landscape and said, look, 85 million jobs are going away by 2025, which is now just a year away, by the way. But 97 million jobs are coming. But what's the problem there? Training. No one knows how to do those 97 million jobs. So we're going to have this large number of people out of work and large numbers of people needed for new work. So both a job shortage and a glut of folks. So what we've got to figure out is how to reskill. And in fact, that same World Economic Forum study said half of workers are going to need to reskill and 40% of their skills need to change, which requires anywhere from 1 to 5 months of training. The average budget for organizations is $1,000 per employee per year. That is nowhere near enough to do this kind of training. And so that's where we're seeing this workforce kind of coming. It's both on demand and persistent, right? You can get kind of a one-off person to help you with something, or maybe they become kind of pseudo part of your team. My team just brought in 3 freelancers so that we can actually kind of ebb and flow with our workflow, because we have a very diverse set of requirements when it comes to workload. We get all of our challenges at the end of the year. They're available globally and locally. Some of these crowds are from around the world, and yet Uber, which is one of those crowds, they'll show up at your doorstep, right? You can get both. You can ask for what you need there. It's people that do grunt work like labeling images, but we've also got experts. We got one presidential innovation fellow using freelancing. We got somebody who is a world expert in wicked problems this way. It's finding those experts that you don't have and don't think you necessarily need to hire full-time. It is these lifelong learners that keep up to speed. There's an axiom that's being kind of put out there now that says, look, if you're an organization, you can almost guarantee you do not have all of the cutting edge expertise you need. But the open crowd community always has what you need for cutting edge technology. And that really has to sink in, because especially at NASA, we think very highly of ourselves, as we should, because we have some amazing people, but we live in a different time that requires us to tap into new technology and bring them in. I will tell you, ARMD is doing a superb job of this right now. They're bringing in some amazing people. And then these platforms are going to get better and better at providing us this low access. So this is kind of my get off the stage chart. Open is really the future. Like, if you think you can do it all yourself, then you don't understand the world we live in. If you think innovation is not something you need in your organization, and it is something, like every organization is needing this. And this is only going to get better. And we really think that this is not just a nice to have, but a must have in the agency. And with that, I'll open it up to questions.
Okay, you guys should be able to unmute yourself anytime.
Okay, thanks, Dave. So if anybody has a question, go ahead and use the reactions, raise a hand. You can also use the chat function. Steve, I just want to say, wow. I don't think I understood half the words that you just said, but they were amazing. So thank you for that. And I've got like a whole page of notes written down that I can't read, so I can't ask questions just yet. But does anybody have a question they would like to ask Steve?
I've got one for you, Steve. I'm up in Seattle now. I see this whole generation of young tech workers. It's just surrounded by Microsoft, AWS. What I see, they just think different. They're transient. They all have a suitcase and a laptop, and it's they just have a totally different mentality. Like, oh, I'm going to stay here for another year, and then I'm going to go to New York, and then I'm going to go to Paris, and then go to London. And what is, you talked about the financial training budget, but what are the biggest challenges? To me, it may be cultural, but what do you think the biggest challenges are to, I mean, you're talking about a worldwide change, not just a NASA change, but what you're telling NASA is you need to jump on this train too.
Yeah,
don't get
yeah.
too cocky.
In fact, we expanded our contract to include free access to freelancers so that our HR and our projects could start to understand what is it like to start to tap into this. And honestly, there's legal issues. There's lots of issues with it. There's a lot you're going to see in the news, big clashes with unions and traditional way of doing business, and companies like Uber and others that are trying to get this other. And this is, I think, one of the largest changes we've seen in the business world in eons. Like it is literally changing the way organizations execute that has been around for 120 years. There's something called this will kind of freak out a little bit, but there's something called the decentralized autonomous organizations, which are blockchain-based digital kind of downloads you can make that create an organization with decision making all built in digitally that you can get, and within weeks execute what used to take months and years for an organization. So you see this shrinking from 90 something years down to 14 years. I think it's going to keep shrinking. If you think about the reason organizations stuck around for so long is once you had a big organization that could do stuff, you just looked for things for it to do because that was the value, right? Was the organization. And what we're seeing now is technology is moving too fast. And so the organizational construct and how we pull people together to do work has to change. It doesn't change the fact that best teams have good relationships and have worked together and have high trust. It doesn't change the fact that you have to have some level of cultural synchronicity to get things done. But we've got to reconcile those things, because the reality is you've got to have a way to bring the smarts in that know the stuff, or you're simply not going to be, the winner's going to be the one that figures out how to do that. So it's a really interesting, but like you say, the culture, these kids are digitally natives. They know how to do everything on the computer, and they're going to leave us in the dust. And they don't care about a full-time job. They want to just go where the good work is. And really, if you think about your time at NASA, all work is project work. Like that's where you have your fun, right? Your loyalty is to that team in that moment. You still have a loyalty to the larger agency, but there is this other kind of piece to it. Okay, there's lots of hands up.
Okay, great. Mary Saramelli has had her hand up, and then I have a question on chat. So Mary, go ahead.
Great.
Yeah, I'm wondering how sustainable this model is. There's millions of potential solutions out there amongst these communities.
Yep.
You might get 90 to 100 solutions to the problem that you put out there, but only one is the winner. What is in it for the ones that are investing their time to create a solution that don't end up being the winner? So are they going to get disincentivized to be putting out all this effort for essentially free to provide you with the solution, but hey, there's was not the winner. So will they stay in those communities?
Right. It's interesting because Harvard, we've been studying this with Harvard and MIT for a while now, and it turns out it is a weird phenomenon. And there may be some people that's the case, but there seem to be more people coming in at the same rate. So you're not seeing a net decrease in the quantity or quality of what you're getting in. Now, the other thing in open innovation is there's actually 4 incentives. We call it the 4 Gs of gold, guts, glory, and good. So, people do care about money, especially if you're going to make money off of a solution, but often they'll do it for altruistic reasons. If you're trying to fix the climate, or if you're NASA, people look at NASA as, I got to do something for NASA. I got to contribute. And even if they don't win, they will send me emails and say, you made my dream come true, because I can honestly say I worked for NASA. I tried to solve one of NASA's problems. And it's funny, the failure is not seen the way we see it. A lot of them will actually fail, but there are no consequences. It's not like when you fail in a school project or you fail at work, nobody cares. And they actually are learning things. There's a lot of kind of like learning that comes with these in these communities. And so I think a lot of in fact, I've talked to several of them, who have literally changed the trajectory of their lives into STEM and learned things and continued to use the challenge platforms as a way to learn. There was a kid from Berkeley who won 5th place on a Homeland Security challenge we did. He won $100,000 as a 5th place winner on an algorithm challenge. He was doing the challenge to learn machine learning. And in his textbook, it said, when you get to this point, go train it with as much data as you can. And the Homeland Security had only given this kind of limited data set. Well, he was a gamer, knew how to create these game characters, and basically created a synthetic data set using his gaming capabilities and made a better algorithm than everybody else. But he wasn't expecting to win. He was doing that for practice. They tried to hire him on the spot and he said no, because he was a freshman at Berkeley. Anyway, but it's a good question. We have not seen that to be the case. And it is totally voluntary. Like, this is, people hear about it and get excited and sign up. But what you find is people want to put their brains to work. There's a great book called Cognitive Surplus by Clay Shirky. And he kind of dives into this and says, people want entertaining, interesting things to do, and people don't invest their lives in engineering and science just to let it sit on the shelf. And a lot of times you'll get, I think that the stats are something like 10,000 postdocs basically come out of the postdoc system every year because they don't get promoted to the head lab guy, to the PI, right? And they end up in safety jobs and industry jobs, but they still have a passion and significant skills that they want to put to use. And I think that's a lot of who you're seeing. That incentive crowd, 75% masters and above. So there's some amazing people out there.
Okay, awesome. All right, so we have a question in the chat, and then Dave will come to you for your question. So the question in the chat is, do you think that academia is preparing students to become part of this emerging workforce that you described?
Yes and no. I'm sitting in Rice campus right now because I just gave a lecture to Mark Jernigan's class. So I have to be careful. The Rice gods will smite me. I think the learning model has to change significantly. I think we've seen it change. I don't know how many of you watch a YouTube video before you go fix your car, but that's learning on demand. And there are new tools for that are kind of interesting. And if you see some of the ways Amazon and Google are basically offering free data science training that after 6 or 9 months, you make $70,000-$80,000 a year. There are some very concerning things about that to me, because, if you get everybody all specialized with no liberal arts, you get a kind of a precarious population of people in terms of who they'll listen to and what critical thinking is. But it's kind of hard to tell. The workforce seems to naturally be adapting to that. No one's advertising, hey, come go work in the gig work. They're all doing it. There's actually a scramble trying to figure out how companies can access them, because they can't. I've had HR people at NASA tell me, I cannot hire people. Have you ever heard that? NASA not being able to hire? And they're like, no, it's taking us 6 to 9 months to find people. And so that's why we want to at least start looking at this and saying, look, we can't just bury our head in the sand here. So is academia doing, I think they can do better at it. I try to get the word out, but it's tough. But they'll also kind of figure it out too. This generation's really good at that.
Okay, Dave, you've had your hand up for a while. Go.
Good to see you, Dave.
Hey, Steve, good to see you. Yeah. So question I've got for you is, have you run any of this by the Moon to Mars folks? Do you support them in any way? Have you presented this to them? I mean, I know they're looking for resilient solutions to the architecture and so forth, and it just seems to me this is the kind of place that this method to get that solution, those solutions.
I have been preaching this since I joined the group in 2013. I was on the road a lot. I will tell you, in 2019, we kind of hit a threshold. We had over right around 100 projects at once, and we had to stop advertising and stop getting the word out. We still have some outreach, and but right now the word of mouth is like, it is overwhelming us. And so our efforts right now over the last couple of years have been scaling. So we're actually putting an innovation academy together where we'll actually rotate cadres of 3 to 5 people through for a year on overlapping 6 months start times, where they learn to do this. They learn to go back to their organization, identify where the opportunities are, and then help us execute, so that the more organizations learn to do this, the more we can actually get more help doing it. So the execution, and we're trying to shrink the execution with the data, a kind of a digital workflow that we're doing. I will tell you, my personal goal before I retire is to try to make this an accessible tool that every scientist and engineer at NASA knows is there, knows when to use it, and how to kind of exercise. It's not something everyone uses all the time. Like, you only use this kind of at certain places, but when you need it, you really need it, and you can't mess around. Like, we only have limited budget, and you can't just kind of churn and then realize, oh, I should have done that. So we to answer your question, we have been working with some of those guys. Some of them back when I was working the Mars architecture stuff, and then some of those folks have moved around, but I think we're fairly well plugged in.
Yeah.
There are always people that I find that do not know anything about us and what we're doing, and it's fine.
Well, I remember, when was it we were doing the starting the NASA at work? That was I remember working on that.
Yeah, absolutely. So that's NASA Spark now, and then it's doing really well. So we're
so one of the things I was kind of wondering about now is, have you overcome the issues that I saw with the NASA at work at that time of folks are busy, they don't have time to go look at NASA at work and see what problems are being posted, much less doing anything. I think that was kind of a WBS funding kind of
so we don't ever post large 40-hour type problems on NASA. We try not to. Every once in a while we will, but we try to stay sensitive to everybody's workload. And what we want is, we want you to at least look at the email, or at least a fraction of people to look at the email that comes out, because what we expect is most people look at the email, they see the 4 challenges that we're running and go, I don't know anything about that, I'm busy, and delete the email. It takes all of 2 seconds, and we're fine with that. What we want, though, is at least look at the headline, right? Because the one time you go, oh, well, that's dealing with quantum sensing, and that's what I'm working on. Well, then you don't want somebody else working on your stuff, because they might get the funding, right? So you're going to actually weigh in on that. The antibody kind of response is going to get you involved, and you're going to say, well, have you talked to Jim over here and Julie over here and me? Because we're all working this already. And that's exactly what we want. We want that collaboration. And I will say that's exactly what happens. And it doesn't actually even have to hit the entire population. It turns out NASA's a really good network of people who know what other people are doing. And they'll go, oh, Adam Schlesinger's actually working on that. You need to talk to him. And that's kind of the way that works.
Have you been able to establish like an innovation work code or something like that? They can charge to and not feel like, well, I'm not working on a project that I've got funding for, because that was one of the things I saw as a potential impediment.
Most of the questions we're asking shouldn't require that kind of time, but when we were initially rolling this out, we had the administrator put out a note that said, look, at NASA, you have 10% of your time that you can put towards innovation. It is yours. Go do it. If anyone asks you, go show them this memo. And line managers are kind of tricky about that.
Oh, that's great. When did that come out?
Oh gosh, that was probably 2015, 2014, somewhere in there.
Okay, yeah, after I retired. Okay, well, good to see you.
Yeah, good to see you. Frank.
Okay, Frank, you've got your hand up. You have to unmute.
Thank you for reminding me. Steve, this is great. I think this is marvelous. And I was thinking about all the things you're saying about training, because I still think in terms of training,
Yeah.
And I really like that group that you kind of keep it growing all the time, growing new people. But when you have a high skills kind of thing, you know, like flying an airplane, flying a space shuttle, it's okay. This thing is great for learning the systems. I'm still wondering how about the eye-hand coordination and all that stuff.
Yeah.
I'm not saying no it in my, I would
No,
love to talk to you, some other people, about
Yeah.
how we approach that, because it's a big one.
I think that's exactly right. And I think, you know, it's real easy to get into binary thinking on this and thinking, well, this all goes away and this is coming. And I think what it really is a morphing of finding that right balance. I do think we're going to move away from the idea of organizations owning people in their entirety. So owning their time, where they work, all that kind of stuff. I think that there's a certain amount that you'll agree to, but people will have a lot more flexibility. I actually recommend to most people in organizations, go get approval for a side gig, because you need to be learning what's out there, and you can intersect in a side gig with other industries that's going to help you with your own work. And, you know, it's along that same lifelong learning. Sometimes it comes with a paycheck too. So, you know, I tell people, go participate on these challenges, go find some freelance work. You're allowed to do that. You just have to get permission. But the reality is almost all of that means what you're really doing is you need to separate out work in a way that people can get all the advantages of what we've built over the long period of time, but still maintain the agility that's going to be necessary. And how do we bring that together? And honestly, I don't think anyone's nailed that yet, but I do think it's going to be an exciting time.
The old time we used to talk about matrix organizations. Now this is like 3 or 4 dimensions of it. I mean,
it really is.
Lots of different
and
places.
I think it's actually the solution to some of the matrix, right? The matrix was, how do we deal with the complexity and numbers of projects with a limited workforce? And if you look at some of the ways these new mechanisms work, they actually allow you to focus people more, which is really, you know, we know is a good thing.
Yeah, I kind of wish I was starting in today again.
What's stopping you?
Nothing at all, actually.
I know how young you are.
That's right. Thank you, guys.
Yeah, great to see all you.
Okay, other questions? Stokes, do you have a question?
Well, yeah, matter of fact, I do. I don't have my hand raised up, but well, Steve, what is your primary assignment? Or
Sure.
Are you working for this for NASA, or did NASA tell you to spread this thing around the world?
Yeah, so here's what's interesting. So I got interested in this in 2010 when I read Jeff Howe's book called Crowdsourcing. And when I read it, I was like, holy cow, the entire way we tap into human cognition has now changed. And NASA needs this. NASA really needs it. And it turns out Jeff Davis and his crowd was already kind of standing up NASA work, and they were pulling in pilots and whatnot. And so I actually got onto that team in 2013, but I was already engaged fully in all we were doing. Since I've gotten on, what I found is a couple of things. One, there's a lot of learning to happen here. Even though it started in the 2000s with platforms and it's been growing, there's a lot of moving pieces, like this whole rapid change in technology. We didn't know that was why this was going to be important. It's kind of the right tool at the right need, you know, which kind of happens with technology. And so I got really passionate about it. I was like, look, I can see a future where NASA's in trouble if we don't figure out how to do stuff with this new stuff coming out. And the way we're doing it now ain't going to do it. Because I've been on those, like, I remember go design a radio for X38, and it was like, well, what's certified? I'm just gonna grab it out. Like, we weren't pushing the technology piece. We weren't even going to ask the technology folks. So it really, it resonated with me. It's like, oh, we have not nailed our technology programs to where we can adapt to this. And it's not just our technology program, it's our entire programs, right? And the way we have to deal with innovation when we are operations and production, which is largely what NASA is, right? We're not as much technology development. means we're even greater risk because budgets are never enough to go buy the best stuff and the latest stuff, right? We're always kind of driven. But let's face it, if we start putting out sub-performing spacecraft, there are others that are going to compare to us, and we have to maintain competitive edge here. So that's why it's so important to me. I really feel passionate about this. The reason I started going around the world talking about this was I was going to other companies trying to find out what they knew. I was trying to, do a quid pro quo on that because this is such an important kind of thing. NASA is one of the few organizations that can talk publicly about this because it's not our competitive edge. And so we do. The fact that we get to work with all these other federal agencies, I mean, we have challenges going on with CDC, the National Institutes of Health, National Science Foundation, the NIST, DOD, like they all come to us and they outspend NASA about 4 to 1. Like they're doing big projects through us. I pitch this up the hill all the time or up the chain all the time, but budgets are tight, right? So how do you get I would much rather every single NASA engineer understand this and they plan it into their budget on how to use it rather than trying to get big money to go do this because, that's kind of dangerous. So I don't know if that answers your question, but. This is the quietest I've ever seen Spencer Gardner, just for the record.
All right. Spencer, do you have a question? Come on, Steve was worried that you were going to heckle him. So this is your chance.
There's no reason to heckle him. I'm enjoying listening to it.
Awesome.
I'm thinking he needs some potato chip stuff.
Yeah, he's heard my story a couple times.
Hey,
All right.
Hey, Steve, can you see if they'll make it so that there's a reward for getting high participation and using that new charge code for innovation?
There you go. Yeah, that's a good idea. I'm gonna have to go look at. I am trying to see if there's a way to tie in this community so that you guys can actually respond to some of the questions that are put out for NASA folks, since you guys have all the requisite knowledge and understanding, and then some. So
Steve, is there a resource you could recommend for us to learn about this?
Well, let's see. If you go to challenge.gov, the government posts all of the challenges that we host, as well as all the other federal agencies. A lot of times you won't know they're through our contract, but a lot of them are. And I would say join a couple of these, join Wazoku or HeroX and get on a challenge. Just kind of familiarize yourself with what they are. There's one guy he's a multi-million-dollar millionaire now. He sits in his garage every evening with a glass of scotch and he just reviews like 4 ideas and he spends about 15 minutes on each one of the challenges. And if he doesn't know anything, he goes on to the next one. But he's solved like 20 of them now. And, they come with these sometimes hundreds of thousands of prize money. So it's a nice vacation. And hopefully I'll have a platform you plug into in the next year or so.
But you mentioned that book called what, Crowdsourcing?
Yeah, there's a couple of really good books. If you want to learn more about the kind of gig open talent stuff I worked with, there's a brand new book called Open Talent by John Windsor and Jen Paik. I can put it in the chat, but it's excellent and it features a lot of discussion of our program as well. Talent, if you just search for Open Talent and John Windsor. I'm not endorsing this, I'm just telling you about it. And then there's several other books that are really good, like Machine Platform Crowd. I think that's the way it says, Machine Platforms Crowd. That's a good one for overview.
Say that again, machine what?
I'll put it in the chat.
Hey, sounds like Stokes wants to sit in his garage with a glass of scotch and work on some pretty gnarly problems here.
Doesn't everyone?
Oh, that's crazy. It'll be tequila.
Okay. Take your
Here
point.
are a couple of sites you can check out. that are pretty good, pretty fun. They have a lot of stuff. Put challenge.gov. NASA has a new NASA.gov called NASA.gov/get involved, and it actually has links to our challenges as well, so you can get to them that way. But it's actually a really good site. It has broken down the stakeholder a little bit better to where if you're an educator or a student or a startup, it's really good.
Okay, awesome. So you're adding to our reading list. Thank you very much. So Steve, are you working on a book as well?
You know, I get that question a lot. I'm not an author. Don't pretend to be an author. I might, when I retire, put a few thoughts down. But know thyself. You know.
Yeah, understand. All right. Any more questions? Anybody have any more questions for Steve before we let him get back on with his life and we all go into our garages with our own personal glass of scotch? All right.
Great seeing faces.
I don't see any other questions. Let me just make sure I don't have everybody on the same screen. So I want to, Steve, thank you so very much. You know, I am always kind of scrambling to find folks to talk. I'm so glad you said yes. It's really great to see you. And this was a phenomenal presentation. I learned an awful lot. I really do have a page of notes that I'm going to have to rewrite because I wrote them so fast I can't read them. Appreciate everybody who joined in on Zoom today. Next month for our first Thursday program, we will be back in the Lone Star Room at the Gilruth. So our next first Thursday meeting is going to be on Thursday, March 7th. We will have a speaker. It'll be a short talk because we're also going to have a special program with an award presentation. I'll put more about that up on the website fairly soon. But if nobody has any other questions or comments for Steve, again, want to thank everybody. Steve, thank you so much for all of this fabulous information. And also everybody for joining. Thanks so much. See you next month.